Hello everybody, I'm Rocket, and today I have a bit of a cold, so if I keep coughing or sneezing throughout this video, I do apologise, but be ready for a loud noise to appear through your headphones at any minute. Today I'm going to be talking all about the leptons, specifically three of them, the electron, the muon, and the tau particle. You've almost certainly heard of an electron in science, and I think I've mentioned all three of them in past videos, but I'm going to be talking about each of them specifically today, starting with the electron. Last episode I mentioned the different types of first, second and third generation particle. The electron is a first generation particle, right up there with the up quark, the down quark, and the electron neutrino. It has a mass that is usually completely ignored in at least GCSE physics and chemistry, but it's equivalent to roughly 1/2000 grams per mole, i.e. you'd need 2000 times 6.022 times 10 to the power of 23 to get just 1 gram of them. They're pretty small, and actually that number, the number of electrons you'd need to have just 1 gram of them, should be appearing on your screen now. Electrons are what carry an electrical current in a circuit, and they have a charge of -1. Because the protons are the only charged particles inside of an atom nucleus, the electrons are attracted to them, which is how atoms have an overall neutral charge, because in an atom there's the same number of protons as there are electrons, and therefore the charges cancel out, and so they're neutral overall. The second particle I'm going to be talking about today is the muon, which is a second generation particle. It has a much bigger mass than an electron. Its mass is 207 grams out of that many particles. It's 207 times bigger in terms of mass than an electron. It's quite a lot bigger. It has the same charge, -1, and in conventional terms that's 1.6 times 10 to the -19 coulombs. Coulombs is the unit of charge used in physics for measuring charge in things such as circuits or powerful electrical equipment. The third and final particle I'm going to talk about today is the tau particle. It's the third generation particle, and it follows a trend of, as the generation of the particles increases, so does their mass. It has 1,520 times the mass of an electron, so which is just over 75% the mass of a proton. Interesting one there. So you need 1,520 of them. You could make 1.52 kilograms with that many, which is 2,000 times Avogadro's constant, tau particles. Now, it has the exact same charge as the electron and the muon, -1, or 1.6 times 10 to the -19 coulombs, and all three of these particles have the same interactions. This means that they are all affected, or can affect, the same fundamental forces. There are 4 fundamental forces: gravity, the weak nuclear force, and the strong nuclear force, and electromagnetism. And these 3 particles are affected by all of them except for the strong nuclear force. This is the kind of force that holds quarks together inside of protons and neutrons, and that holds protons and neutrons together inside of atomic nuclei. But I'm going to talk more about that in later videos, because the 4 fundamental forces are all controlled by bosons, which are particles that I'm going to be covering in the future, in the next 2 and 3 weeks. This was quite a short video today, guys, because as I've said, this series is made up of twice as many videos, but they're all quite short, because there's really not that much information to convey on each individual particle. However, thanks for watching, guys. I'll see you next week when I won't have a cold and I'll be able to talk for a bit longer. Sorry. I'll see you next week, guys. Please like, comment, subscribe, and I'll see you soon. Bye.